Hey everyone, my name is Nabil Fahel and welcome to our Terminal Tech Talk series. This is one of the funnest parts of my job and it's an absolute pleasure to be with everybody. If this is your first time joining us, welcome. If you're a returning guest, welcome back. At Terminal, we believe in bringing global opportunities to global talent. So if you are not familiar with our business and you want to learn more, just head over to terminal.io. But basically, we believe in that talent is universally distributed, but opportunity is not. So we're trying to bridge that gap by bringing global opportunities to global talent. So basically, in whatever community you find yourself, it's Terminal's mission to try and bring those jobs to you as opposed to have you move to where those jobs are. So if you are interested in any of the exciting job opportunities that we have as an engineer, just head over to terminal.io/openings. In terms of our talk today, we have a great speaker. Tam Kabali is the founder of Code Core College, and he was the lead instructor. He's subsequently sold that business and he's now focusing on new ventures. And right now he's the founder and CEO of Codecast, which you'll learn a little bit more about today. But Tam is Vancouver based and he moved to Vancouver when he was a student. And then he loved Canada so much he decided to stay. That's kind of a common thing that we're seeing as well across the board. And we ourselves at Terminal have moved a lot of talented people into the country to take on all kinds of interesting roles. I want to thank Eric and Zoran and other people who are helping us make this live stream possible from the Terminal end. But without any further ado, I'd love to pass it over to Tam Kabali. We've hired people out of Code Core College. We love Code Core College and the Vancouver ecosystem. We have offices all across Canada, now in Mexico as well as Colombia, and we're going global with the Terminal model to bring global opportunities to global talent. So without any further ado, I'd love to just pass it over to the presenter to give us the presentation. And along the way, I want to make sure that all of your questions are answered on the fly. So at the bottom of your screen, you'll notice a little chat roll widget on the live stream page. Feel free to pop in questions there at any time and we'll get to them. Sunsky and Lucio have already asked their questions in advance over email and we'll get to those ones first, but we'll get to the questions on the fly throughout the program. So if you have any other questions, I'll talk to you on the chat roll widget, but without any further ado, over to you, Tam.
And hello, everybody. Nice to meet you all. Thank you for taking the time out of your busy afternoon or evening to attend my talk. Today, I'll be talking to you about building high-performance web apps with Elixir and Phoenix. Topic I'm very passionate about, so I hope you're going to enjoy this presentation. Like Nabil said, I'm the founder of a platform called Codecast. I'll show you a little bit more about it later. It's basically a streaming video platform for developers. Previously, I've founded and sold a coding college called Code Core. So you can think of me as in part, part entrepreneur and part developer, mostly back-end web developer. The reason I'm mentioning this is because it will shed some light on my decision for being so excited about the Elixir language and the Phoenix framework, because in most cases I seek things that are practical. You could build apps with it, launch it, have real customers on it, and all that stuff. But at the same time, it's fun and enjoyable to write with, because these days, those two things tend to be trade-offs or opposites. I think that's that gap is being closed slowly with Elixir and Phoenix. I mostly have JavaScript and Java, some PHP and C# a long time ago. This is why the examples I'm gonna use in this presentation are gonna be primarily comparisons, mostly Ruby and JavaScript actually. That's again in a short presentation, it's hard to compare with every framework or every possible language out there. But at least if I compare with these two, you get at least a bit of an idea for my reason for liking the Elixir and Phoenix. Like Nabil said, at any time in the presentation, please ask your questions. I'll be looking regularly to the chat, and I'll basically be taking a look and hopefully answering them as they come along. So let's talk about Elixir first. So what is Elixir? Elixir is the programming language. So the talk is Elixir and Phoenix. So Elixir is a programming language. Phoenix is a framework. It's a functional programming language. It's dynamic, and it's built basically on another language called Erlang. So it's created by this guy. His name is Jose Valim. He actually came from the Ruby community. This is why you will notice, as you will see some of the Elixir code, it is heavily inspired by Ruby, even though the language is completely different. Ruby being object-oriented and Elixir being a functional language, the type of coding is very different, but the syntax is similar in many ways. So some of you may be wondering, what is Erlang? Erlang is another language. It's actually been around for a very long time. It's created by Ericsson in the 80s or 90s, and it's created to be fault tolerance, high performant programming language. And it's basically built for telecommunication purposes, to power routers and switches and call centers and data centers. So that's why, unless you've worked in the telecom industry, you probably haven't encountered Erlang as a language. So you may be wondering, how come Erlang hasn't caught as much steam as it should, considering it actually has a very rich and vibrant, in a way, ecosystem, although it's somewhat under the radar. I'd say in big part it's primarily because the syntax and the way you code in Erlang is actually not that easy, not that approachable. It's a little hard sometimes to read Erlang code, a little hard to code and modify Erlang code. And this is where Elixir comes about. It basically compiles to the same output as Erlang, which is the Beam or Erlang VM. Elixir can actually leverage pretty much all the libraries you can get with Erlang. So you could use the entire ecosystem of Erlang, plus adds a lot of the things that are specific to Elixir. So you're basically getting all the performance gain, fault tolerance, multi-threading capabilities, a lot of the things you get with Erlang, with much, much approachable and easier syntax. So the language is basically purely functional. We'll talk a little bit about functional in the next section because it's an important aspect of Elixir. It's very fast. Also talk a little bit about the performance later. It's elegant. I mean, the elegance is coming in big part from getting better syntax, better way to write code than what Erlang came about. Again, Ruby is probably one of the nicest languages syntax-wise out there, and Elixir is inspired by it to some extent. And it's very approachable. Sometimes functional languages can be intimidating, require some math background or some highly abstract concepts. That's not the case with Elixir. And it's going to look familiar. The code is going to look similar to most of the code you've written before, even though it's completely functional. So here's an example of a line in Elixir code. Even if you've never seen Elixir code before, this line, you may be able to guess to an extent what this line is doing. So as you can tell here, we have string that we pass it, and we downcase it, and then we trim it, and then we replace duplicate spaces with a single space. This operator may not be as familiar to you, which is the pipe operator, which is basically passing the output of one function as a first argument to the subsequent function. So you look at this code, and again, even though you may not be fully familiar with it, or you may be used to more like chaining kind of code with say, Ruby or JavaScript or Java, you may look at this code and you at least can guess to a point what it's doing. I guess, the language, as I mentioned, is very approachable. Syntax is very friendly to developers who are new to functional programming. So you may be wondering, I've been using the word functional. Probably many of you know it, but in case you don't, I'm going to talk about programming and why is it important. Functional programming comes down to really just one core concept, which is immutability. There's many other aspects of functional programming. I'm just a little bit oversimplifying here, but at its core, functional programming languages basically prevents you from modifying data once you put it in memory. So you could delete it, you could copy it, but you cannot mutate it. It seems simple, but it actually has huge implications for how you write code and how you execute code. So, for example, here, in a non-functional way of doing things, you could have a structure of some sort. Could be an object, could be some data structure, could be just data and memory. And the function in a non-functional way can potentially mutate the data right in memory. So even if there are multiple threads or multiple processes reading, they'll actually, be reading. One of them could mutate that data. In a functional way, the fact that you're enforcing immutability, what you're really doing, you're making copies of objects all the time. So basically, if I want an object with the triangle modified, what I'll have to do, I'll have to make a copy of that object or that data structure. I should avoid using the word object. Any kind of structure of some sort or collection of data with a new copy with the modification I want in place. So it does have a bit of an overhead right there, but it does actually have many other advantages. So, why functional and why is it picking up steam? It's been around for a very long time, by the way. Why is it picking up steam right now? For multiple reasons. First one is the fact that Moore's law is dead. So we're getting to a point, many of you are probably familiar with Moore's law that says, we could double the amount of transistor in a chip every 2 years or so. It's been true for a long time, but we're getting to the end of this, mostly because of just physical limits for what we're able to do on a chip. So we're getting to a point where, if you recall in the 80s, well, I was too young then, in the 90s and 2000s, every year you get a new computer and it's actually significantly faster than the previous generation's computer. These days you get a computer, you get more memory on it and stuff, but you're not getting ones that are significantly faster than say last year's model or something like this. In big part because what's happening is, again, we're hitting physical limits of just putting more transistors on chips. So what's happening is, if you notice, you're coming with, quad cores and 8 cores and 16 cores processors. So you just have more cores on them rather than just having more transistors on the same core. So doing parallel programming, programs that run in parallel is becoming more and more important. Can you do it with non-functional language? Absolutely. But functional programming makes it a lot easier to basically do parallel programming. Because if you have 2 threads reading the same spot in memory, you're 100% sure that memory is not going to be changed, because the only way you could change it is by making a copy of it, which means you haven't really changed it. You just made a changed copy of it. So it makes writing parallel programs a lot easier than non-functional ones, which you have to do locks and use some other constructs to make sure that the data stays consistent. It really also enforces good habits. So you can write good code in any language or any framework. That said, when you have a language that forces you to have good habits, it just makes coding, code quality better for everybody, especially for people coming new to the project or new to the language. So with functional programming, the fact that you can't mutate variables, it really means you have a lot less side effects about functions. Every function is basically just an input and an output, and your program will be completely composed of just one function passing output to another function who does something with it, pass it output to another function, and so on. So it will be like a series of functions. So if you know the input and output of every function, generally speaking, your program will already enforce a lot of good habits. I mean, it's kind of like, being on a diet and having a jar of cookies in your kitchen. It makes it harder. If you're able to mutate data, it's kind of like the same thing where, sure, you can write good code in any language, but the fact that the language enforces those good habits, I think it's a really good thing. And functional languages tend to do that. And because every function has just simply an input and output, then what happens is, if you know the input and you know the output, it's easier to test and it's easier to refactor a particular function. So it makes things like testing and refactoring your code much, much easier. So what's the catch? Why doesn't everybody code in? Doesn't everybody use this and that's it if we're getting all these benefits? To be fair, coding with immutable data structures is actually not that easy, especially when you're first coming to it. In many cases, you may not even be aware of how much, say, your framework or your library is actually mutating data in memory. That when you take this out of the equation, now you have to rethink the entire way that you're doing the application. So here I'm comparing side by side 2 pieces of code. One is using Elixir and Ecto, which is a library that helps you connect to the database. And there's an equivalent Rails one called Active Record. So you're noticing here I'm having to do more work with Elixir to achieve the same outcome, but with a lot less side effects. So in this case, what I'm doing, I'm trying to create a user with an email, just making sure that the email is present, the email is required. So in here, you may not be aware, but in the Rails version, Rails is actually setting a flag for you, a Boolean, whether the record is valid or invalid. That's actually being mutated on that particular object. In here, what I am having to do, I'm having to basically call a series of functions, and the same one I want to create to know whether something is valid or invalid, rather than setting a flag on a particular record. Again, that's a very contrived example, just to give you an idea that the catch here is that you will spend a little bit of time getting your head around how to code in a functional manner. Once you get used to it, it'll get significantly easier. I would still say like writing in a mutable data structure is still a bit easier, but once you get used to the functional way of writing things with immutable data structures, it will get a lot easier. So what is Phoenix? Well, Phoenix is a framework to build web applications with Elixir. It's in big part what popularized it even a lot more. There's many things that you could do with Elixir on its own. There are libraries that help you like connect with hardware, write code for hardware and whatnot. But with Phoenix, you could actually write high-performance web apps using the Elixir language. It's been created by this guy, Chris McCourt. Again, you can find him the same as Jose on Twitter. It is inspired by Rails. So again, not to be surprising here, is a lot of some of the concepts like the patterns, the structure, and things like this are inspired by Rails, but it's a lot less magic. Anybody who's coded with Rails knows that Rails ships with a lot of magic, what you would call it, basically ways that does a lot of things for you without seeing explicitly what it does, and it's a lot less opinionated. It's a lot less opinionated when you're for the choices that basically come about. So in my opinion, Phoenix is doing the best of both worlds. It's basically you're getting a lot of patterns that is proven to be useful with Rails, plus you're getting functional programming, and plus you're getting the high performance provided to you by the Erlang Virtual Machine. So this is one of the big reasons I really like kind of the trade-offs that are being made in here are basically in a way that I think it's really striking a great balance between having good patterns, functional programming language, and high performance all in one package. I'll take a little pause here. So Carlos is asking, what do you think are the main differences, advantages, disadvantages between Elixir, Scala, and Clojure when choosing a functional programming language? I haven't coded significantly in Scala and Clojure, to be fair. I've coded in a very brief manner. I would say, though, that from my limited experience there, just syntax and approachability-wise, I find Elixir much easier to learn than Scala. If you're in a situation where you want to use the JVM, the Java Virtual Machine, like your infrastructure, your other parts of the app are using the JVM heavily, I would say probably Scala will be a better choice for you. If you're starting from scratch as a language, it's more elegant, more approachable, easier to learn, and actually leveraging the EVM, which you will see more of the Beam, the Erlang Virtual Machine. I think Elixir will be a much better choice. So I think it's really kind of as a first language, a functional language. From what I've seen, Elixir is probably one of the best, if not the best. But there are other reasons like Clojure. Yeah, thank you guys for questions. Keep them coming. I'm happy to pause at any time to do the questions. So I will show you a little bit of code for Phoenix a little bit later. But before this, let me just talk a little bit about the performance. So how much performance gains are we talking about here? So this is actually a print from an app we're using in production that, for example, here I'm rendering the search page, and here I'm rendering the home page. Both pages have quite a bit of HTML actually in them, like they're large pages. You're noticing here, you actually read this wrong. This is actually microsecond. So this whole request takes less than a millisecond to render. And this request takes 4 milliseconds to render. And this is running in dev. Again, no caching, no optimization of any sort. So right off the bat, just by simply sticking with the Phoenix framework, you're getting huge performance gains. I mean, to mention some of the gains you're getting out of the box. For instance, if you've used Rails or JavaScript, again, those are the two I'm familiar with. Usually you have view files that are text files that needs to be parsed and rendered. And from my experience, those usually take a fairly long time because you're doing a lot of string replacements, you're patching usually different partials and whatnot. In Phoenix, they're actually compiled as functions. So they're run extremely, extremely fast. So that's one of the many reasons, other than just the raw performance of the language itself being, running on the beam being extremely, extremely fast. So right off the bat here, you're getting huge, huge performance gains from using Phoenix. Show you a couple of others, profiling that some other people have done here. So the founder of the Elixir language, Jose, he did this performance here, which you could check it. I'll link to it in the slides. By the way, those slides will be shared with you guys later, so you don't necessarily have to take screenshots or anything. So he did basically performance here between a variety of frameworks, including Gen, which is a Golang one, Play, which is a Scala one, and of course Rails Sinatra. And you're noticing here, and then Express, you're noticing that Plug, which is a library that Phoenix uses, is also Elixir. And Phoenix are really significantly faster than say Rails. We're talking here even more than 10 times, or even 100 times faster. Again, run those tests yourself and check it. Right off the bat, you're getting huge performance gains from using Elixir and Phoenix as a language and framework. Other benchmarks being done here, just again, this person is comparing Phoenix with Rails on different instance sizes on AWS. Again, you're noticing here, for example, 300,000 versus 60,000. So we're talking 6-7 times. Similar here from 500 to 8,000. Again, talking 16 times. So again, huge performance gains just using Phoenix off the bat. No caching, no optimizations are needed. The last bit I want to talk about a little bit is a relatively new feature in Phoenix, which is called LiveView. I'll show you a bit of a demo on it later, which is, again, a dream come true for a backend developer like myself, where it allows you to write a lot of heavily interactive code on the page itself without having to write any JavaScript. Actually, you could write JavaScript if you want to, but you could do a lot of things just with plain backend code by opening a socket between the front end and the backend and re-rendering the parts of the DOM that basically need to be changed. So, Nabil, if you wouldn't mind, can you share the link of Codecast? So Codecast, one of the features we have in Codecast is the ability to live share code. So here's an example of a Phoenix project, which is right here. So just give me 1 second to pull it up. If you want to follow this code along, check out the chat. Nabil will be sharing the link for the Codecast shortly. So this is using LiveView. So I'll show you here a very simple application. So let's look at this one here, for instance. This is a classic snake game. Oh, clearly I'm not great at this game. So what you could do here, as you notice here, I'm playing a snake game. Probably implement this as Java. What might surprise you is that this entire page right here have 0 JavaScript written on it. The entire thing is happening on the back end. So how it's being done? It's basically just you re-render the parts of the view that changes, the part of the HTML and the DOM that changes. Every time a change happens. In this case, every time I hit a key, I basically send through the sockets a request that pushes back changes for the DOM that needs to be changed and gets re-rendered. Because of the ability for Elixir to run things concurrently, really out of the box, and the fact that it's just high speed makes something like this possible and actually quite performant. So here's an example of, you'll see it on Codecast of an application. This is basically this demo application written all in Phoenix. So walk you briefly through it. So here you notice we have this demo web, which is the web part of the application, which has controllers and templates and views. It's basically a way, kind of, if you're familiar with an MVC architecture, that should come a little bit familiar to you, where you have a controller that's basically rendering a page right here. You have a template that's basically rendering something in here. So in this case, I do a change, example demo Phoenix. Again, there's a live socket that happens all the time. So what happens is my app every time will basically re-render. Every time I make a change, it will re-render what I'm doing right here. So you have templates, you have controllers, you have views. And off the bat, this is one thing also I like about the Phoenix framework. It separates the application logic from the logic of the app itself, from the like controllers and views. So you put your real code, the stuff that connects to the database in this demo, and then you put the things that connects with the web in this demo web. Also, you have your assets, which is basically Webpack-powered asset management system. Probably familiar with whether you're using, it's popular on most frameworks. So back to the snake game right here, a lot of the LiveView stuff will go in this live folder. And the entire snake game that you saw is actually written right here. So this is, for example, the board you're seeing at the top here for the snake game. Even though it's being rendered here, we could completely put it in a view file you may be familiar with. And then those different functions will respond to things like arrow left, arrow down, arrow up, arrow right, and all that stuff. So, with writing, again, this has no JavaScript in it whatsoever. It doesn't enable you to inject JavaScript if you have to, so you could use them concurrently if your application requires that. But in many cases, actually, just writing this is enough. It's so fast and cheap to open a socket with a client that you could do it at a relatively low cost and render things on the server. I think it's a super cool feature. We've been using it in production for some time now. So here's an example. So if you have something like filtering, where I'm filtering some records right here. So I'm filtering by like province. So notice here, as I'm changing like the drop-down menu, changing the cities, the number of records being shown here is being filtered as I change my things here. So if I put here something like, as you notice, as I type, also things are being changed. This is completely done on the back end. Again, zero JavaScript I had to write for this particular piece of code. And in my opinion, again, being a backend developer, having less reliance on JavaScript for a lot of for the simpler type of things, it's very important. It's inescapable. You're going to use a lot of JavaScript in your app. That said, if there are things, another thing we use regularly, for instance, is server-side validation. We use LiveView for a lot of these things. Again, super performant and production ready. Really, really cool stuff. Highly encourage you to check it out. So we did the demo. Yeah, let's talk a little bit more about what makes Phoenix a great choice, in my opinion. Phoenix has basically packages, like libraries for the most popular use cases. Like you want to upload a file, you want to connect to a particular popular API, you want to do, OAuth or something with Facebook. There are libraries for this. There are libraries to help you throughout the entire stack. Like I've encountered very, very few cases where, I needed a library of some sort that wasn't there. I would say some other systems are more mature, like Rails has a lot more gems and libraries that do even more things. Use cases, it's basically grown to a point where you're not going to be hindered because a library is not there. And I think that's a very key aspect to me, again, from being a pragmatic, practical way of choosing a framework. Like, for instance, we looked at Golang and Rust as other good new programming languages coming about. One key issue was for web applications, they had fewer libraries that basically didn't fewer libraries that make it little harder. We had to write a lot of code by hand to do some core things in our application. While in Phoenix, I think you're going to find packages for almost everything. Phoenix has an awesome and growing community. If you ask a question on Stack Overflow, on Elixir forums, they have Slack, Discord channels, there are always people helping you out. There's many companies using it in production these days, like Discord, for instance. You've probably heard of it, like a Slack competitor kind of a thing. PepsiCo have many of their part of their online presence. It's built all powered by Elixir and Phoenix. Many big companies are actually using Phoenix and Elixir live for their application. So I would say it's getting to a point where the community is big enough that you're not going to be, say, stuck in something or any type of situations. Indeed, one good kind of litmus test, if you Google regular things, you see answers for them for that particular language. And almost a lot of the things I Google about Elixir and Phoenix, I see people already have asked the questions, have already answered it. So it's usually a good sign that there's a lot of community, a lot of people asking and answering questions. Lucio is asking, I have software company that mostly works with PHP, Falcon, Vue, and Quasar. I'd like Elixir Phoenix advantages in REST API development over PHP, Falcon. Again, here, just back to the points I've mentioned earlier. It's, great questions, Lucio. So, maybe it kind of dives into this one here. Like a good developer, you shouldn't use one language or one framework for everything. There's usually like a right trade-offs in a particular framework that makes it suitable for certain scenarios and not suitable for others. So PHP and Falcon, I've heard good things about them. I haven't actually used Falcon myself. I've used PHP a while back, like I mentioned. What I found is that Phoenix code, Elixir specifically, just with the functional aspect of it, the code is significantly more maintainable down the road. So the trade-offs become something like this. If you have expertise in the team for, say, PHP and Falcon, you want to build a quick app for a client and just launch it, and the client is less likely to need significant modifications for it, I may pick something like Rails, or in your case, PHP and Falcon, if you have expertise in-house for it. You may get to the market quicker. It may be cheaper for your client, and it could do the job. It could be fast enough, performance. That said, if you want to build an app that's going to last for a long time, needs to be maintained, likely to grow, likely to have more features added to it, likely to have developers revolving on it, it could be totally worth it in investing in Elixir and Phoenix. The performance, the maintainability you're going to gain from it, I think it's going to outweigh the short-term costs of having to spending a little bit more time to write code, or spending a little bit more time to train your people on. Being a Rails developer myself, I would still write apps. If, let's say, I'm building an MVP for a new idea, a minimum viable product, I would still find it faster to write it in Rails. That said, in the long term, I think that curve kind of crosses at some point where actually writing it in Phoenix becomes actually faster when you start to have to maintain large apps. I know, as a very simple example, at some point in Rails, you would have to write a lot of caching to make your app perform better. That's something you probably never have to do, as an example with Phoenix. That's a very simple example, but the code quality itself and the good habits, I think, it's totally worth as an investment for the long term. Again, from my other expertise, Express has the advantage of having your entire stack in one language, which is JavaScript. Again, I tend to be biased with this. I don't like JavaScript as a language. I think it has some core design flaws, but that's purely my opinion. Even with that, Express apps tend to go a little bit too big, a little bit hard to maintain, a little bit unmanageable, I would say, in some cases. That I think it's worth investigating using Elixir and Phoenix again, because you will get a lot more performance and a lot of it. But like the other things, if you have more JavaScript expertise in your team, you want to build a app of certain size that Express is good for, I think it could be completely fine. And needless to say, by the way, just again to recap this whole thing, you can write good code in any language or any framework. I'm just saying that Phoenix and Elixir enforces good habit. That's what it is. It just encourages people to write better code. It doesn't guarantee you're going to write better code. It doesn't guarantee you're going to write bad code in other languages. Just that little nudging toward writing better, more maintainable code, I think it's worth it. I would say the biggest challenge in Phoenix these days is finding developers who are already trained with Phoenix. What I would say here, if that's kind of your biggest hindrance, it's relatively quickly because of how approachable and how easy they made it to write code in Elixir. I think it's relatively easy to train up developers to become proficient, productive in Elixir and Phoenix. I'd say this is probably mostly applies for developers who have done some coding in the past. It may be harder for pure juniors to just jump into Elixir. But that said, I could be wrong. It could be an easy first language to learn. But I just found it, just a functional aspect of it makes some parts of the programming a little bit harder. So any experienced developer can pick Elixir and Phoenix relatively fast, especially if they've done, say, something like Express or Rails or some type of an MVC architecture. That's number one. Number two, there's a trend even in JavaScript that people are doing functional JavaScript. So they're applying the functional aspects of programming into JavaScript, which is non-functional at its core. So if you have these two, I think picking up Elixir and Phoenix wouldn't take a huge amount of time. So again, but that said, it is a smaller pool of people simply because it's a newer framework. It's a newer language, so that's something to keep in mind as you're choosing Elixir and Phoenix as the framework for your project or company. Deploying Elixir and Phoenix apps is actually relatively straightforward. You have Heroku support in it. If you're not familiar with Heroku, it's a platform cloud that makes it super easy to deploy apps. It supports many languages these days, like PHP, Java, Rails, Express, you name it. So all you do is usually you push to Heroku, and then they set up the server for you, and then they deploy it. And then they automatically set up the database and many other services for you. Now they support actually Elixir and Phoenix. We use a service called GigaElixir, which has few more features and few more customizations for Phoenix apps. You could even use AWS, Docker, and standard other deployment methods if you want to. Indeed, with the Erlang ecosystem, you could technically have your entire stack with pure Erlang. You don't necessarily have to, and in many cases, you do choose to use a combination of other languages or frameworks. So, for example, here, background jobs, like, in most cases, if you want to have recurring background jobs in, say, Ruby and such, usually you have to use cron and sometimes bash scripts to just have a recurring thing. You could actually have this just part of your app. Running within the Erlang environment. What other things like server? Like there's built-in servers in Erlang. Again, it's highly performant. Most Ruby developers use something like Puma or Nginx or Fusion Passenger as the front end when you're deploying. You could use pure Erlang there. So I foresee more and more things kind of coming down the road to have like just pure Erlang servers. You can support the whole entire stack for you. Encourage you to check out a lot of the things. In the short presentation, it's a little hard to cover all the concepts and principles. Things like OTP, pops up, Gen server, some of the core things in the Elixir language and the Phoenix framework that are very powerful tools that allow you to accomplish a lot. All within the same code base without having to pull in a lot of components from outside. We get a question earlier from Sunki. He asked, nowadays I notice a lot of teams are migrating to serverless architecture, and when they're often adopt cloud services like AWS Lambda, how does Elixir fits into this trend? I'm interested in what could be a more robust way to deploy an Elixir and Phoenix app in cloud environment. Because of how fast does it run? Generally speaking, I found you need a lot less servers than normal to run actually to have like really large throughput of data. So you'll actually naturally need a lot less servers. But one thing is, which by the way isn't necessarily a bad solution, it's just you have now more servers that you need to take care of and manage, and you have to watch for certain things like race to the databases and whatnot. With Elixir and Phoenix, by default, you basically need less servers. So you actually need a lot less servers than you normally do. But even with those ones you need, I think just standard deployments with as I mentioned, using like Heroku or Gig Elixir could be sufficient enough. Now, specifically talking about serverless architecture like AWS Lambda, as far as I know, it doesn't support Elixir like as a straight up language. From what I remember, as of a couple months ago, you support things like JavaScript, Python, Ruby, C#, and I think Java. Those are the languages I remember that are supported, and Golang. Now, I did hear that AWS Lambda, for instance, they're supporting like a kind of, you push your own runtime environment. So it is technically possible to deploy Elixir on a serverless. You just have to basically do your own runtime environment or find somebody who's built a runtime environment for Lambda. It's just not supported off the bat. But in my opinion, we haven't needed it so far. Like just deploying on standard servers is fine. By the way, one popular app that leverages Erlang to a point is WhatsApp. I mean, WhatsApp powers hundreds of millions or even billions of users these days. And they run with a relatively small team. I think like 100 or a couple hundred engineers compared like supporting these number of users, and a relatively small number of servers. I don't remember the exact details, but check out, like if you're curious more, check out of how WhatsApp scales with their infrastructure and just the number of engineers by using Erlang. Okay. So are you ready to drink the Elixir? So let's say you're sold and you want to give this a shot, whether for your side project or next service you want to use. How do you get started? And actually here, Aiden is asking what's the recommended paid or non-paid resources to learn Elixir and Phoenix. Yeah, so I would say, just something I want to reemphasize over and over, it's relatively easy to learn. I mean, the languages I mentioned earlier are the ones I've actually pushed to production with, like Ruby, JavaScript, Java, PHP, and C#. There's many others I've tried that are not, I didn't push code to production, so I didn't list them there. But I found Elixir is one of the most approachable, easy to learn language. So don't be intimidated. You don't really need math or CS theory to dive into functional programming. Don't let this functional aspect of it intimidate you in any way. So I would say, just go dive right in. Some of the resources, first of all, I want to mention that documentation is great. The Elixir documentation is awesome. The Phoenix documentation is awesome. Even some of the Phoenix ecosystem parts like Ecto, which is the database connection library and stuff, also have great documentation. Well laid out, good examples, good design, easy to search. So I usually start there when I'm building my Rails apps. If you like books, I recommend these two books, Programming Phoenix by Chris McCord, Bruce Tate, and Jose Valim. Again, the creator of Phoenix, the creator of Elixir, and Bruce, who's a great teacher. Also, Programming Elixir, just Steve Thomas, forwarded by Jose Valim, also a great, awesome book. If you like books, I think those are great ones to start with. Pragmatic Bookshelf have many other Elixir-specific books. Ones that are in OTP and some very specific, some of them are a bit more advanced. They have some LiveView, screencast, and whatnot, so you could check them out. If you like, other kind of teaching, Elixir School is one that I should say it's more like text-based, but it's laid out in a nice curriculum, and it's kind of well maintained. It's a good one to start. Again, if you prefer more like books, you could think of it more like a book style, put in a curriculum kind of a thing. If you prefer more video types of courses, I've taken a few on Udemy, and they're great. Those will be paid ones. Pluralsight also has a couple. There's also some interesting content on YouTube. Check out, for example, Zero to Hero in Elixir. That's basically a good one to check out as the first one. Another guest question here: is it a junior developer job because of the smaller talent pool? Actually, it's a very good question. I haven't thought of it from this angle before, but that could be extremely. That could be a very smart way to do it. Yeah, I would say, I'd say these days it's probably becoming more possible, especially that more companies, because remember these days still there's a lot more companies using, say, Rails and Express and Java as backend than, say, Phoenix and Elixir. So there are fewer companies overall using it. That's changing. But now that more companies are open to remote, I think the pool of jobs is starting to grow that's available for you in a particular geographic location. I would say as a junior Phoenix developer, I think it could be very interesting. You know, for example, in Codecast, and there's another project I'm involved with, we would be looking for people with Phoenix and Elixir down the road, Phoenix and Elixir experienced developers. So finding a junior who has done that, I think, would be a great plus. Again, it's a little bit hard for me to speculate for the entire market, but my hunch would be that it would be an advantage. It would certainly make you stand out from the many others who just focus on, say, React, right? React tend to be a popular framework for juniors to learn. So if you learn Phoenix and Elixir, I think it could make you stand out as a junior developer. Another thing also, if you're interested in Elixir and Phoenix, I'm going to be doing a series on Codecast. Codecast is a platform I'm currently building. We're still in beta with Codecast, but I am planning to put a lot of content, starting with a lot of Elixir and Phoenix. It's going to be mostly free content. Probably all of it will be free. So email me if you're interested. I'll put you on a mailing list, and I'll email you when basically we're ready to launch this course. So yeah, I mean, as I mentioned here, I'm the founder and CEO of Codecast. We're building like a video streaming platform for developers, where we're enable developers to stream videos alongside code, which hasn't been done as of yet, in an interesting new way. We're still in beta, early days. So my pitch to you guys, if you want to create content of some sort, whether it's in a course format, workshop format, or just like little tidbits or something, we're looking to partner with anybody who's looking to do paid or free content. We'll help support you, we'll help you promote and build your content. We use Elixir and Phoenix, by the way, for the backend. So, again, it's been a great choice for handling, many requests coming, handling diffs, even like we've had hundreds of people connected to a session at the same time with no blip in performance or anything like this. So I'm talking to you of experience when I'm talking about Elixir and Phoenix. Another great question from Aldo is like, how does testing ecosystem in Phoenix? Do you think it's easy to reason about any downside on this? Actually, I'm a kind of person, I wasn't too crazy about testing per se. I used to write tests in Rails a lot, but I used to find it cumbersome to set up the test. And I used to find it cumbersome to maintain the test, because sometimes you have something that have an unintended side effect that could break a whole bunch of tests. Indeed, one of the biggest advantages, I think, of using a functional language, including Elixir, it's not something unique to Elixir, I think, but just the fact that every piece of code. So I'm going to go to the code a little bit here. So just like, for example, if I go to a piece of code here, let's say this demo here, and I go to this, to this here. So I have something called the change set in this module right here, which helps me do things like validating a particular record or something like this. So all I have to do basically here, so to test this, I have to provide it input and check the output. That's it. I don't have to do anything else. I just have to call this change set. I have to give it this user, which is basically, it could be like a map, kind of like a key value storage, and an attribute, which is a keyword list. Again, I don't want to dig too much into the details. I know probably most of you aren't familiar with Elixir. But the idea is, if I give it this input and I check the output, I basically know that my function works well. Because again, I'm not afraid that this function is going to have side effects beyond what's right here, beyond just getting an input and give it an output. I'm confident this function will not do that. I won't be confident in this in something like Rails, for instance, because a function could actually modify something else that could break tests. So I would say in general, we found testing to be, quite straightforward, a lot easier than when I used to code in Rails. And we didn't need to do a lot of, we use some libraries for, say, mocking and for doing things like mimicking HTTP requests. So you can mimic the response from an HTTP request. But beyond this, just the X unit, which is the testing framework that ships with Elixir, it's just by itself sufficient to write tests at scale that are relatively maintainable, easier to read. So the short answer is I think it's great, and actually one of the advantages I think of using a functional language like Elixir. Let me go back here. Okay. Another question. So Elixir was scalability. What are the biggest challenges you face in terms of scaling Elixir applications horizontally? I would say, honestly, when you want to scale something like, when you want to scale the application, I mean, we didn't have to scale significantly horizontally at the moment. We have a handful of servers. We didn't really face any major problems per se. What I would say in most applications that I faced with Elixir and Phoenix, usually the bottleneck will become the database, honestly. Like the app will take care of a lot of the things. And then what you get in terms of scaling, it's really scaling the database, which is a whole different topic on its own that you probably have to do even in other ecosystems that are not specifically like Elixir. Even in Java, sometimes you want to scale, you have to scale your database. In Rails, you have to scale, you have to somehow scale your database. So I would say, the biggest challenge would probably be scaling the database, whether it's scaling the queries or the infrastructure of the database or optimizing the database itself. But from my experience, it has been these things. There could be some other issues that I haven't encountered yet, but so far, that has been it. But because it solves so many other problems that I think even if you end up facing some things with scaling horizontally, I think you have enough bandwidth because you're not going to have to worry a lot about the infrastructure right there. So I'm reaching the end of my presentations here. If you have questions, please keep them coming. We still have a little bit of time. I just want to take a moment to thank Terminal for putting this together. Nabil and the guys at Terminal are doing a fantastic job. As you mentioned earlier, many of my friends and previous students speak very highly of the companies that Terminal basically hosts into their community. So again, if you're a developer looking for your next challenge or something, you could check out Terminal. Indeed, Nabil told me at some point probably they still do have some Phoenix jobs available. So if you're intrigued enough, you could probably take a shot at like getting a job as a Phoenix developer. So that's my information. I'll share this presentation later. Shoot me an email or hit me on Twitter. And I think if you have no questions, I'll probably pass it back to Nabil. And if you have any questions later, I'm more than happy to answer them via email or on social media.
That's
so I'll give it
wonderful.
Back to Nabil now.
So much, Tam. Thanks so much for that wonderful presentation. We definitely look forward to staying in touch with you. We definitely look forward to staying in touch with the individuals that joined us here today. I'll definitely send everybody who joined us today the deck, as well as the link for the Codecast code. I'd just like to wrap it up by thanking everybody. I know like here in Canada, we have 4 terminal offices, and we've been really fortunate to be able to create about 300 jobs in 3 short years at Terminal across about 44 different partner companies that we brought to Canada. And we're doing the same in Latin America. I know that we have a number of guests and friends that are joining us from Mexico and some from Colombia. And on that note, we're going to have our very first Terminal Tech Talk in Spanish, on Español. So if you're interested in that, I will definitely reach out to all of you. Or actually, my colleagues Oscar and Daniel will be reaching out to those individuals to share the details of that Tech Talk, which is coming up next month. We do these Tech Talks every single month, and the next one is going to feature a very special software developer who used to be on Google's Android team for 4 years, but he's subsequently moved over to Zoox, and now he's working on autonomous vehicle and autonomous mobility software. Don't want to steal the thunder of that. We're going to send you all the details of that. But with that being said, I just wanted to thank everybody for joining us wherever you are in the world. We love doing these live stream programs. Doing things live is a little bit tricky, but we're getting better and better at it, and we hope that you would consider joining us in the future. But with that, it's a wrap. So Eric, on the live stream, you could wrap it up. Thank you.